Okay, so we're again recapping Arithmetic Sequences series from yesterday. And you could have started your sheet. I did pass that out, but I don't know if you guys did or not. So we talked about yesterday how a sequence, again, is just a series of numbers, and how it's just basically a collection that's been like kind of organized and ordered. And again, we talked about how there's a finite sequence and an infinite sequence. And so we looked first for the pattern. So if we recall back from yesterday, remember we had -3, -1, 1, and 3. And so what was the pattern again? Everybody's awake today. So it was a +2. So then remember, from there, then we said, okay, what are the next two numbers of the terms? And you guys said 5 and 7. Okay. And then the next one we were looking at, we were having 3, then 9, then 27, then 81, and then you guys said what was the pattern? So times by 3, or you could think of it as exponential. You could think 3 to the first is 3, 3 squared, which would have been 9, and so forth. And so then remember, what was our next number in the sequence? 243. And then what was the other one? 729. Okay. And then we talked about how this is our summation symbol. And then, so we use the Greek letter sigma for that. And again, it just talks about how we're using those particular terms. And I'll show you how to do a little bit more with summation today. Okay, so again, it's basically a fast way of adding things up. Instead of having to add, like, what's the sum of the first 50 integers? And you don't want to have to put that in your calculator and go 1 + 2 + 3 + 4. There's a shortcut. And so that's kind of what summation is all about. So being able to do that. Okay. And so we've kind of covered 1 and 2, and then we were kind of getting going on some of these, and then we ended up making it, I think, to number 5, if I recall correctly, for you guys. But again, let's just kind of recap. So for an arithmetic sequence, this is going to be my bread and butter formula that I need. Okay, so that is my formula. So, anyways, so first thing we looked for is just looking for to see whether it was arithmetic or not. That means they need to have a common difference. So remember in our first example, we had 1 to 4, so that's a change of how much? 3. And then 4 to 7 was a change of 3. 12 to 7, though, was a change of 5. And 12 to 17 was a change of 5. Are these all the same? No. So that's why we said, is this sequence arithmetic? No. Why? Because the number's different. We need to have the same consistent number. Okay? And then when we looked at number 2, okay, 26 to 23. So -3. What about 23 to 20? Does that say the same throughout? Yes. So then, is this arithmetic? Yes. Why? Because it's the same number all the time. -3, -3, -3. Okay? So can we tell the difference between an arithmetic and what is not arithmetic? Okay. So then, for number 3 and 4, we talked about first finding the pattern, then writing the equation, and then we want to find the 20th term. And so we talked about yesterday how we don't want to just do it, like list every single one of them out, because that takes too long. Okay? So first we want to figure out, okay, 3 went to 9, 9 went to 15, 15 went to 21. What's the difference in my terms? What's going on? +6, right? Everybody okay? +6. So that's my D. Okay, so I'm using this equation right here, or this one that's here, whatever one you'd like to look at. And so we're going to write an equation for this. So a to the n is equal to a to the 1, remember, was our first term of the sequence. So what is our first term in the sequence? 3. And then plus, and then we're going to have n minus 1, and then we're going to have the d, which is 6. And then, of course, we use the best property, distributive. So we're going to have 3, and then 6n minus 6, put together our like terms, so my final rule is going to be 6n minus 3. And so the reason we do that, so now if I want the a to the 20th, so I want the 20th term in the sequence, I can just plug 20 in there, and I got the answer. So we did 3 times 20, probably not 3, we can't think today. 6 times 20, which is 120, and then 120 minus 3. And so if you recall from yesterday, that's where we got that 117 number. People were gone yesterday if I'm going too fast. Let me slow down, I'll slow down. Okay, the next one, what do we see for a change? So what's the change? What's happening all the way across? Minus 5. So my d is equal to negative 5. So we have that. And then from there, we're going to write our rule. So we're going to have a to the n equals my first number in the sequence, 8, plus n minus 1 again, and then negative 5 is my d. That, again, needs to be distributed out. So we're going to have 8, and then we're going to have negative 5 times n, which is negative 5n, and negative 5 times negative 1 will make a positive 5. So my rule is going to be a to the n is equal to negative 5n plus 13. And then we're going to find a to the 20th term. And so therefore I'm going to plug 20 in here, and I'm going to multiply that out, get negative 100, and then negative 100 plus 13. And so yesterday we said negative 87. And then that's kind of where we stopped yesterday. So that's kind of a quick crash course for some of you guys that were gone yesterday and what we were doing. Okay, so now what we're going to be taking a look at today is writing the nth rule. So we're going to talk about what happens though if they don't give me the sequence. How am I supposed to come up with the rule for it like I'm doing in number 3 and number 4? So we're going to take a look at that. And then also we're going to take a look at how do I find the sum. And so those are the things that we're going to be looking at for today. And then we'll start taking a little bit of a look at geometric sequence and series as well. And then we'll eventually get to story problems and then review and all that fun stuff. But not today. Okay, so for writing a rule for the nth term of the sequence, the problem is, do I know what the first number in the term, the sequence is? No. So that's part of my problem. And I can't really find the d right now because I'm not looking at a full sequence. So what we do is this. We're first going to figure out we're going to use this rule that I have here to kind of help me out. So what we're going to be doing is this. We're going to say, okay, let's just work this out. So let's say if it's just a to the 8th, okay? So a to the 8th, we're going to put that value in here. So that's going to be 59. Okay? I don't know what A1 is. Oh, well. Okay? And then from there, what we're going to be doing next, I just want to double check what I'm looking at here. Trying to think if that's the way I want to approach it or if there's a better way to approach this one. I suppose it's fine. Okay, then plus. All right, remember how this is going to be n in my case for now. So what's 8 minus 1? 7. Do I know the difference? No, so I'm just going to call that that. Can I clean this up a little bit? Yeah, we're going to do that in a minute. So then I'm going to write another equation because I'm going to have to write another one. So now this one's going to be 99, which is the 13th, so that's a to the 1. And then 13 is my magic n. So 13 minus 1, which is 12. Okay. I don't necessarily need the parentheses, so like here I could have just called this 7D. Anybody have an idea what we're going to do with this thing? This is a system. We're going to subtract it. This is a system of equations. Remember doing systems of equations? Because if we subtract, what's going to happen to my A1s? They're going to go away, right? So then we're going to have, what's 59 minus 99? So negative 40. And then if I subtract this, I'll get negative 5D. And so divide by negative 5, what's D? 8. Okay, this is cool because we just figured out what my D value is. So we can write get ready to start writing the equation. The problem is now I know D, but I don't know A1. So remember, what did we do when we had a system of equations and I knew one of the answers? Plug it back in. So pick an equation that you want to plug 8 back into. So let's say we pick the top one. So we're going to have 59 equals A1 plus, and then we got to do 8 times 7, which is 56. Everybody okay so far? Okay, what do you think we're going to do to find A1? Subtract 56 both sides. So what's A1 equal to? 3. So now do I have the right information? Yes. So now I can write my basic equation. A to the n is equal to, what's my first term? 3. And then I keep the n minus 1 now. And then what was my d value? Which was 8. And then just leave it like that, or you could actually clean it up a little bit too, which would probably be nice. So this would just be 8n minus 5. And so that would be my rule. So now I know I can find any term of that particular sequence by doing that particular approach. Okay. So a lot of times with sequences, we want to be able to figure out the sequence. Also, though, sometimes we want to add terms all together in a sequence. So we want to do something called a sum. And so that's what we're going to be looking at next. So when we're looking at a sum, we have this particular formula here. Okay. And so what's going to happen is your S of n is going to be the mean of the first and the nth terms multiplied by the number of terms. So like, for example, if we want to find this sum right here, I mean, most of you guys, unless you want to just take the long way around, you could just do 1 plus 3 plus 5 plus 7 plus 9, da-da-da-da-da-da-da, right? Okay. But if I want to find a sum, I can actually do this quicker instead of doing 1 plus 3 plus 5 plus 7 and so forth. So what we can do instead is this. So we can say, let's find what the sum is. And then first thing we want to do is count how many terms we have. So how many terms do we have? 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this says take 10 divided by 2. And then what is the first term in the sequence? 1. What's the last term in the sequence? So this is supposed to be a shortcut, so we don't have to put in our calculator 1 plus 3 plus 5 plus 7 plus 9. So instead, we do this. What's 1 plus 19? 20. And then we got to figure out what 10 over 2 is. 5. So we really are doing 5 times 20, which is what? 100. And then if you wanted to check it, you could actually just stick it in your calculator and do 1 plus 3 plus 5, but you're going to get 100. So this is a shortcut, so we don't have to necessarily do that. Okay. Here what we're going to do is we're going to find the sum of the first 150 terms. There's no way we're going to want to calculate that. Okay. So there's no way we're going to want to list 150 terms out and then add them up with a calculator. That's crazy. Okay. So what we have to do is kind of use a shortcut. Okay. So the shortcut again, so we're going to find the sum. How many terms are we looking at? So how many terms do we need? 150. So we're going to have 150 over 2. Okay. Now we have a small problem that we're going to have in a second, but we'll get to that. So what's your first term? Cool. What's my last term? Don't know. Aw, man. That's not cool. So we're going to have to use what we were doing before. We're going to have to figure out like what the D is. We got to write an equation. We got to find what the 150th term is. We don't want to list them all out. That's crazy. So this is what we're going to do. So what is the difference? How is this changing? So how is this changing? Changing by 11. Everybody okay about that? So my D is 11. Okay. So now we're going to start writing that rule that we were doing earlier. So we're going to have a to the n. What was my first term? 5. Plus n minus 1 times d, which is 11. Let's clean this baby up. So we're going to have 5 distribute. So we're going to have 11n minus 11. And so now I'm going to have 11n, 5 minus 11 is 6. This is a lot nicer to work with. Now what do you think we're going to put in for n? 150, yeah. So we're going to do 11 times 150 and then minus 6. And then that will give me my last term. So my last term is 1644. And then now we can calculate. So I can do 1644 plus 5. You'll get 1649. And then what is 150 over 2? Yep, so now we got to multiply that number by 75. And then this will give me my sum. And so my sum is going to be 123,675. And so that's my answer. What do you think? So hard? No, it should be pretty easy. You know, arithmetic sequence and series are just kind of straightforward, easy, nice, happy. They're very nice. Okay, last one we're going to take a look at is, let's say we have a brick patio that has this shape of a trapezoid. And so the patio is going to have 18 rows of bricks. We're going to have the first row is going to have 14 bricks, and then the 18th row is going to have 31 bricks. So how many bricks are in the patio? So what would be the long way to do this? Count them. That's nuts. Nobody wants to do that. No, you don't. So what you want to do instead is, again, think about your summation here. So we have our S of n, that's what we're trying to figure out. So what do we have for our first row? Because that's what we're going to need. Okay. So the first one in the row is going to be 14. And I'm kind of jumping ahead of myself. So first I have to think about also, how many rows do I have? 18. So we're going to have to do 18 divided by 2, because again we're going to be having 18 rows. All right, so we have 18 rows. Again, it's divided by 2 because of the formula. And then, so 14 is my first term. What's my last term? 31. I love this one because it's a plug and chug kind of one. And so we just have to do what 31 times or plus 14 is. So what would that be? 45. And then 18 divided by 2 is 9. So I'm really doing 9 times 45. And then that's going to end up giving me my answer. So what would be my answer? A big number, but not really that big. And so 405. And then label. So what's faster, doing it this way or counting every single brick? Yeah, funny about the counting. Not true. Okay, so questions about arithmetic sequence and series. Okay, we're also going to get started a little bit on geometric.